solving trig equations, what the video no one wants to make, obviously, so I'll make this video. So we have 7 tan theta is equal to 2 times square root 3 plus tan theta. We want this solved on the interval 0 to 2 pi. So I'm going to start out, frankly, just solving this as if it was an algebraic equation. I'm going to try to get all of the tan thetas to one side. I think it's probably a good idea. So what I'm going to do here is I'm just going to add negative tan theta to both sides as if it was x. You know what I mean? So minus tan theta. And 7 tan thetas minus 1 tan theta is 6 tan thetas, isn't it? So 6 tan theta is equal to the 2 square roots of 3, right? Now what I'm going to do, again, the whole game for me doing this kind of crap is that I'm kind of pretending that what I have is this, and this is used a lot in calculus where you just kind of use some kind of substitution. So I'm kind of looking at this as if it said 6x is equal to this, right? So if that was true, then I think we could agree that what we do is we divide both sides by 6, wouldn't we? So we get tan theta is equal to 2 over 6 is 1/3, isn't it? So we get square root 3 over 3. So, okay, so this starts to not look, it starts to look very encouraging, and then it goes to crap altogether. So hang in there with me for a second. I want you to remember something, that tan theta is really sine theta, isn't it, over cosine theta. And we want that to equal the square root of 3 over 3. So here's some good news. We don't have to look all the way through the unit circle. As we look at the unit circle here, we realize that this is the positive positive, isn't it? This is the negative negative quadrants, and this is just the Cartesian plane, isn't it? So here, if I had sine over cosine, I'd have a positive over a negative. Here, if I took tan of theta, I'd have, excuse me, I'd have a negative over a positive. But this thing is positive, isn't it? So we know that we're only going to look in quadrants 2 and 3. So I'm going to look in quadrant, I'm sorry, 1 and 3. So I'm going to look in quadrant 1, and I find that this angular value works. If I go to pi sixth, right? If I go to pi sixth, then we would have sine of pi sixth is 1/2 if you're looking on your unit circle. And and cosine of pi halves is square root 3 over 2. We know this is a complex fraction, so it's going to come up like this, isn't it? So we're going to get 1 over square root 3. And I'm sure you're asking me, how do I make that equal this? Because that's what it has to equal. Remember that we're not allowed to have a radical in the bottom, so what we do is we rationalize this, right, by doing this. And we have 1 times square root 3 is square root 3. And square root 3 times square root 3, remember, is square root 9, which is 3, isn't it? So one of our answers is pi sixth. So pi sixth. So theta equals pi sixth. And that's in quadrant 1. And in quadrant 3, I think we find 7 pi sixths. We find 7 pi sixths. And we find out there that sine is negative 1/2. Cosine is negative square root 3 over 2. We're going to do exactly the same work that we did before. We're going to end up with 1 over square root 3. Remember that we can't have this here, so we take square root 3 over square root 3, and that's equal to square root 3. And remember, square root 3 times square root 3 is square root 9, which is just 3. So the other value is that theta, our angular value that we're interested in, is 7 pi sixth. Let me tell you what happened if you were struggling with this. You're like, Charlie, what are you talking about here? I'm totally lost with you. The next, I would really challenge you to go and get a copy of the unit circle and then watch this video again and take your little copy of the unit circle and you can follow exactly what I'm doing. So that's what I have. So you really have to know the unit circle. And also you have to know that this stuff is not easy. Some people say, a lot of people argue that this is actually more difficult than calculus. And I have some proof of that, and my proof of that is that there aren't very many people doing videos on trig equations because it's a real pain in the, as I was saying, have a great day. I hope you are subscribed to me already. If not, I hope that you'll do that, and your comments are always welcome. Ciao.